Hypothalamus Artificial Intelligence, HI, and Research Center for Advanced Decision Technologies, RCADT, presents the conference. Industry 4.0 Digital Transformation. The chicken of golden eggs of the enterprises. Or, Operations Research, billions of dollars in social and economic benefits. The fundamental support of smart computing is the mathematical modeling of the organization that has produced billions and billions of dollars in benefits. From the above, it can be deduced that optimization based on mathematical models is a great business opportunity in first world countries and in developing countries. For more than 4 decades, winners of the Edelman Award have been recognized for transforming how they approach some of the world's most complex problems. The 2020 finalists are no exception, with revolutionary contributions in robotics, cruise industry pricing and booking, railway planning and productivity, IT system sustainability, corporate decision-making, and retail inventory operations. Finalists for the Edelman Award have contributed to a cumulative impact of more than $292 billion since the award's inception. The list of winners of the Franz Edelman Award for Achievement in Operations Research and the Management Sciences, from 2000 until 2021, are presented in the table. On the other hand, Jeffrey Alden, of General Motors Analytics Research says, more than $336 billion U.S. dollars of impact. Since 1974, Edelman competition finalists published their project accomplishments in the Informs, Institute for Operations Research and Management Science, Journal on Applied Analytics. These conservative guidelines exclude important yet difficult to quantify reported benefits, such as improvements in legal dispute resolution, cancer treatments, airline safety, epidemic disease control, organizational structure, on-time railways, space shuttle heat shielding, and water quality. Below are some brief presentations from the 2022 Edelman Awards. 2020 Franz Edelman Award was won by Intel. The tech giant receives coveted award for integrating product architecture design with supply chain planning. Below are the success stories reported by the finalists of Edelman 2020. Intel has earned $25 billion by applying advanced analytics, from product architecture design to supply chain planning. Intel is faced with efficient product feature design along with supply chain planning, which is critical to Intel's economic success given its scale, the complexity of its products and manufacturing processes, and the highly capital-intensive nature of the semiconductor business. In response to an exponential increase in complexity, Intel developed an innovative set of capabilities, using advanced analytics, that span product feature design through supply chain planning with the goal of maximizing revenue and minimizing costs. This set of capabilities is fast and efficient, allowing many more scenarios to be analyzed in much less time than previous solutions, while delivering superior results, including faster response to customers. Implementing this capability across the majority of Intel's product portfolio has generated average annual revenue and cost reduction benefits of $1.9 billion and $1.5 billion respectively, with a total benefit of $21.2 billion to date, contributing to Intel's environmental goals of reducing water use and preventing wastewater. The paper Operations Research Enables Better Planning of Natural Gas presents the use of mathematical optimization models for pipeline planning. China's natural gas consumption has nearly doubled in the past 5 years. To better meet demand, the China National Petroleum Corporation, CNPC, China's largest producer and supplier of oil and natural gas, partnered with researchers from the University of California in Berkeley and Tsinghua University in Beijing to apply operations research to develop and implement new software to help CNPC to improve the management of its pipeline network. Previously, all pipeline production and construction planning for CNPC, which controls 72% of the country's natural gas resources and 70% of its pipeline network, was done by traditional methods using spreadsheets. However, due to the increasing size and complexity of the network, the use of the traditional method resulted in excessive costs and wasted resources. Since implementing the new software, which uses a 3-stage convex relaxation method and iterative piecewise linear approximation methods, in late 2014, CNPC has obtained approximately $530 million of American dollars in increased earnings, 2015 to 2017. In addition, the resulting increase in the efficiency of the existing pipeline network allowed the company to postpone the addition of new pipes, leading to an official budget reduction of more than $20 billion of American dollars in construction costs for the following 5 years. The image present the algebraic formulation of the natural gas pipeline transmission model. Without fear of being wrong, it can be said that mathematical optimization models are the goose that lays the golden eggs of China National Petroleum Corporation. Competing on analytics, the new science of winning. And analytics at work, smarter decisions and better results. In the middle of the first decade of this century, Thomas Davenport and Gene Harris published the book Competing on Analytics, which makes a difference in the way operational research solutions are marketed, since it did not change the content of the methodologies used. At the beginning of the last decade, IBM published a revised diagram of the one presented by Davenport and Harris, which describes the benefits provided by analytical methodologies. Regarding of mathematical modeling complexity, IBM classified the levels of analytics into descriptive, zero math modeling complexity, predictive, medium math modeling complexity, and prescriptive, high math modeling complexity. Stochastic optimization is classified as the superior methodology, capable of managing the effects of uncertainty on the decision-making process. IBM dismisses stochastic simulation as a competitive technology. Meta-heuristics are not included in the diagram. The capacity of the methodologies is analyzed from 2 points of view: degree of complexity, and competitive advantage. It is clearly seen that the contribution of the methodologies is differential, not all contribute equally. This implies that knowledge generates competitive advantage, due to its greater ability to handle complex situations. Regarding descriptive analytics, it can only be said that its contribution is minimal and that in practice it is not analytical. Davenport and Harris classify the types of professionals who participate in the labor market, such as amateurs, they can use spreadsheets; semi-professional, they can use visual tools to create simple models; and professionals, they can create algorithms. This excludes semi-professionals from creating prescriptive analytical models, as it is always necessary to create an algorithm for a specific problem of a particular company. Industry 4.0 has changed the landscape for analytics professionals. The two main changes are: a new professional activity emerges, cognitive robots that code complete decision support systems. To achieve this, mathematical models are stored in expert systems, which can be populated by artificial intelligence tools, such as a pre-trained generative transformer, GPT, and analytics professionals design the mathematical model and coordinate the load on the expert system, but they do not make programs. Analytical semi-professionals and analytical amateurs are not seriously affected by Industry 4.0. IBM believes that an intelligent organization should be anticipatory, empowering, open-minded, aware, linked, and precise. In times of radical change, being open-minded is essential. To do this, the company must reserve the right to be smarter, questioning its status quo while creating new opportunities. It is necessary to think and act out the box. The other two qualities that the company must achieve are anticipation and accuracy. This is achieved through the intelligent application of mathematical methodologies. It is not a question of power, it is a matter of intelligence. It is not a question of doing, it's a matter of doing it correctly and accurately. The other two qualities that the company must achieve are anticipation and accuracy. This is achieved through the intelligent application of mathematical methodologies. It is not a question of power, it is a matter of intelligence. It is not a question of doing, it's a matter of doing it correctly and accurately. The table presents the comparison between a traditional and an intelligent organization, published in the IBM article, Business Analytics for the Intelligent Enterprise. Jeremy Shapiro, professor of the Massachusetts Institute of Technology, says, "The primary benefit of a DSS is the explicit reduction in costs and the increase in profits. Cost reduction of 8% performed by our client is not atypical. In our experience, the integrated analysis of planning problems, using mathematical models, determines strategies between 3 and 20% cheaper." Many companies do not allow them to publish their positive experiences, as they consider that an advanced decision support system gives them a competitive advantage. In 2014, IBM estimated that companies in the energy and utilities sector, which used big data and analytics, reported 23 times higher productivity than those that did not. Smart computing drives the new era of IT computing. Analytics is one of the pillars of the so-called smart computing. This is based on the statement of Andrew Bartels of Forrester Research, who in the study Smart Computing Drives the New Era of IT Growth states, verbatim, "Analytics is one of the pillars of the so-called smart computing." This is based on the statement of Andrew Bartels of Forrester Research, who in the study Smart Computing Drives the New Era of IT Growth states, verbatim, "Smart computing is a new generation of integrated hardware, software, and network technologies that provide IT systems, with real-time awareness of the real world and advanced analytics, to help people make more intelligent decisions about alternatives and actions that will optimize business processes and business balance sheet results." Smart computing is a new generation of integrated hardware, software, and network technologies that provide IT systems, with real-time awareness of the real world and advanced analytics, to help people make more intelligent decisions about alternatives and actions that will optimize business processes and business balance sheet results. Human brains, a swarm of neurons. Artificial brains, a swarm of algorithms. The future. Artificial brains, a swarm of algorithms of mathematical programming. In 1962, the Dutch mathematician Jacques Benders published his theory of partitioning, which is a transcendental, not the first, step in parallel computing, aimed at solving complex mathematical problems, dividing them into more elementary subproblems. The author believes that Benders never perceived that the true importance of his research lay in the fact that he had established the way in which two algorithms would communicate with each other, and they could become a universal language for communicating a swarm of algorithms. If large-scale multi-level optimization methodologies, based on the partitioning and decomposition of systems, are applied to obtain the smallest atom of a dynamic stochastic model, the number of algorithms they generate could become countless. If parallel processing technologies, such as microservices, are used, the solution of a mathematical problem would be carried out by a swarm of algorithms, working autonomously and permanently, to achieve the goal proposed by the decision maker. This algorithmic swarm approach is currently used, in artificial intelligence, to manage swarms of robots, but the rules that robots follow are simple, logical and intuitive, and do not have a universal mathematical basis. An artificial brain can be visualized as a swarm of algorithms, cognitive robots, which have a communication structure based on a multi-level dispersion matrix, and whose communication protocol is governed by mathematical laws aimed at obtaining results as a team. This algorithmic swarm approach is currently used, in artificial intelligence, to manage swarms of robots, but the rules that robots follow are simple, logical and intuitive, and do not have a universal mathematical basis. An artificial brain can be visualized as a swarm of algorithms, cognitive robots, which have a communication structure based on a multi-level dispersion matrix, and whose communication protocol is governed by mathematical laws aimed at obtaining results as a team. Joseph Louis Lagrange was an Italian mathematician and astronomer, whose main idea is Lagrange multipliers, a strategy to find the local maxima and minima of a function subject to equality constraints, using the implicit function theorem. Lagrange's seminal idea is to convert a constrained problem into such a form that the theory of an unconstrained problem can still be applied. The principles of Lagrange theorists are still the support of optimization, but solving real problems using their techniques is no longer valid. Without knowing it, Lagrange generated the foundations of communication between cognitive robots, which speak mathematics as their natural language, allowing them to move like an artificial hypothalamus. Artificial brain is the evolution of decision support systems in the Industry 4.0 revolution, which is conceptualized as a set of mathematical models that autonomously exchange information with each other, working online through distributed optimization. The diagram presents the components of an artificial brain from a shipyard. There are now in the world machines that think, that learn, and that create. Moreover, their ability to do these things is going to increase rapidly until, in the visible future, the range of problems they can handle will be coextensive with the range to which the human mind has been applied. In the book Human Problem Solving, wrote by Alan Newell and Herbert Simon. Thank you very much for your attention.